The Subcommittee on the Environment will come to order. Welcome everyone to today's hearing entitled A Factual Look at the Relationship Between Climate and Weather. And let me also say that we have a little bit of a sparse attendance today for two reasons. One, there are members of the Republican caucus who are still hearing what the budget deal is all about. I expect them to trickle in shortly, and we've lost both Republican and Democratic members to a Nelson Mandela Memorial Service. So we're down in numbers a little bit, but not down in interest or in making a record thanks to the expert testimony from our witnesses today. I'm going to recognize myself for an opening statement, then the ranking member. Administration officials and the national media regularly use the impacts from hurricanes, tornadoes, droughts, and floods to justify the need for costly climate change regulations. President Obama stated in his 2013 State of the Union address that, quote, "We can choose to believe that Superstorm Sandy and the most severe drought in decades and the worst wildfires some states have ever seen were all just a freak coincidence. Or we can choose to believe in the overwhelming judgment of science and act before it is too late," end quote. However, the overwhelming judgment of science does not support the President's claims. According to the Intergovernmental Panel on Climate Change, Ipcc, there is high agreement among leading experts that long-term trends in weather disasters are not due to human-caused climate change. The story is the same when we look at each type of extreme weather event. Hurricanes have not increased in the U.S. in frequency, intensity, or normalized damage since at least 1900. It has been 7 years since a Category 3 or stronger hurricane made landfall in the U.S. Government data also indicates no association between climate change and tornado activity, whether measured by the number of strong tornadoes, tornado-related fatalities, or economic losses associated with tornadoes. The latter half of the 20th century shows no climate-related trend. The data on droughts yields similar results. For example, the National Oceanic and Atmospheric Administration concluded that climate change was not a significant part of the recent drought in Texas. And the Ipcc found that in some regions, droughts have become less frequent, less intense, or shorter. Ipcc's latest report also states there is low confidence in any climate-related trends for flood magnitude or frequency on a global scale. The science is clear and overwhelming, but not in the way the President said. The fact is there is little evidence that climate change causes extreme weather events. Instead of trying to scare the American people and promote a political agenda, the administration should try to protect the lives and property of our nation's residents from extreme weather by better weather forecasting. This committee last week passed bipartisan legislation to do just that. The Weather Forecasting Improvement Act of 2013 strengthens our nation's ability to save lives and property through advanced research and implementation of next-generation weather forecasting abilities. I hope this hearing will make clear that the impact of climate change is often exaggerated. Politicians and others should rely on good science, not science fiction, when they discuss extreme weather. Otherwise, they will lack credibility when advocating new policy changes. That concludes my opening statement, and the gentlewoman from Oregon, Ms. Bonamici, is recognized for hers.
Thank you, Mr. Chairman. Today we continue what's been a popular topic for the subcommittee and indeed the committee at large. What impacts, if any, the changing climate is having on our daily life and the lives of our constituents? It's not likely that the committee will reach consensus on this question anytime soon, but nonetheless, I welcome and appreciate the witnesses who are here today. Dr. Titley, I'm interested not just in your experiences at NOAA, but also your work for the Navy, where you rose to rank of Rear Admiral. And I know I speak for the entire subcommittee when I say that we're grateful to you for your service to the nation. Dr. Titley's work has been at the interface of weather and climate through his long career with the U.S. Navy and now at the Pennsylvania State University. There's a long list of good scientists who would be capable of appearing before us today to shed light on the facts of the relationship between climate and weather. Actually, I would like to see more of them come before this subcommittee and the committee in the whole, because whatever our diverse views are on climate change, there is absolutely no disagreement that severe weather events can devastate our constituents, deprive them of their livelihoods, and sometimes even take their lives. Ruling out research into a potential link between climate change and severe weather events would be burying our heads in the sand. Recently, I worked with members of the subcommittee on what is now bipartisan legislation to address the federal weather enterprise and how it might be improved to provide our constituents with better warning of severe weather events. I know my constituents on the coast of Oregon rely on weather forecasting information that can tell them when it's safe to go out fishing. My constituents in Yamhill County need information on weather patterns to help make decisions about the grapes they grow to make world-famous Oregon Pinot Noir. And if we're here to learn that it's erroneous to associate any given day's weather or any particular storm with climate change, that's fine. However, climate change challenges us to think in terms of decades of accumulated change. Making comments on today's weather is easy. Learning what factors might influence long-term climate patterns is significantly more difficult. Our constituents should be able to count on their elected leaders to take a difficult look at a complicated subject. The lesson of this hearing cannot be that a potential link between climate change and severe weather is too difficult to determine or understand, and therefore we should stop trying. It should not be controversial to examine if the weather will change as a consequence of global warming. Scientific projections from the Ipcc make it apparent that we will live in a hotter world. We already have a warmer world than that of our grandparents. And many of our district's residents will experience drier environments with more drought. Those of us who represent particularly wet areas may find that precipitation arrives in more intense storms. The oceans will be warmer, and that may well produce stronger or more frequent tropical storms. To focus only on the question of whether there will be more extreme events misses the point that by the end of this century, much of the world as we know it, in our districts, and in the states and across the world, will be considerably altered by the weather effects of climate change. We need to face up to the risks of global warming and do more to reduce carbon emissions. Americans have always boldly faced risks and challenges. Our own armed services have already begun taking climate change seriously. The Navy, as Rear Admiral Dave Titley could attest, has been struggling with the strategic implication of year-round open seas in the Arctic. In summary, anthropogenic climate change is real. There is a strong consensus that we are already seeing climatic consequences from warming. The continued warming of the globe will have profound impacts on our country and on the world. This situation creates an opportunity for the United States to show leadership in reducing carbon emissions as well as in adopting and mitigating the effects of climate change. Finally, I want to join the chairman in noting that I do not want the absence of more members on my side of the aisle to be perceived as a lack of interest in this important topic. As the chairman noted this morning, there's a memorial service for Nelson Mandela at the National Cathedral, and many members are attending that service. Thank you, Mr. Chairman, and I yield back the balance of my time.
Thank you, Ms. Bonamici, and let me introduce our witnesses. Our first witness today is Dr. John Christie, Professor and Director of the Earth Systems Science Center at the University of Alabama in Huntsville. Since November 2000, he has been Alabama's state climatologist. Dr. Christie has served as a lead author, contributor, and expert reviewer for the UN reports by the Intergovernmental Panel on Climate Change, which included satellite temperatures as well as other climate data sets he constructed. Dr. Christie is also a fellow of the American Meteorological Society. He has served on 5 National Research Council panels or committees and has performed research funded by NASA, NOAA, DOE, DOT, and the state of Alabama. Dr. Christie received his master's and doctoral degrees in atmospheric sciences from the University of Illinois. Our next witness is Dr. David Titley, Director of the Center for Solutions to Weather and Climate Risk at Pennsylvania State University. Dr. Titley served as a naval officer for 32 years and rose to the rank of Rear Admiral. Dr. Titley's career included duties as Commander, Naval Meteorology and Oceanography Command, Oceanographer and Navigator of the Navy, and Deputy Assistant Chief of Naval Operations for Information Dominance. After retiring from the Navy, Dr. Titley served as the Deputy Undersecretary of Commerce for Operations, the Chief Operating Officer position at the National Oceanic and Atmospheric Administration. Dr. Titley holds a master's degree in science in meteorology and physical oceanography and a PhD in meteorology from the Naval Postgraduate School. Our third witness today is Dr. Richard Pelkey, Professor of Environmental Studies and Director for the Center for Science and Technology Policy Research at the University of Colorado. Before joining the faculty of the University of Colorado from 1993 to 2001, Dr. Pelkey was a scientist at the National Center for Atmospheric Research. Over the past 20 years, Dr. Pelkey has collaborated with researchers around the world to publish dozens of peer-reviewed papers on extreme weather events and climate change. He is also a senior fellow of the Breakthrough Institute and holds academic appointments at Macquarie University in Sydney, Australia, and the London School of Economics. Dr. Pelkey holds degrees in mathematics, public policy, and political science, all from the University of Colorado. We welcome you all. Look forward to your testimony, and Dr. Christie will begin with you.
Thank you, Chairman Smith and Ranking Member Bonamici, for the privilege it is to offer my views on climate change. I'm John Christie, Professor of Atmospheric Science at the University of Alabama in Huntsville and Alabama State Climatologist. I've served as a lead author of the Ipcc years ago. My research might best be described as building data sets from scratch to advance our understanding of what the climate is doing and why. Have climate extremes of the past 50 years been unprecedented? To answer that question statistically, one needs 1,500 to 2,000 years of data with which to compare. Only then can one determine if the characteristic is unusual. For a few extremes, such as drought, we have long data sets. In the 12th century, there were mega droughts, far worse than any we've seen in the past century. As noted in more detail in my written testimony, when the comparison is done properly, to label today's events as extreme usually fails the test of time. Now to the Ipcc climate models. On the screen, the figure, you will see a 35-year record of atmospheric temperature in the tropics, the key region in which climate models respond to greenhouse gas warming with a large and distinct signal, and was used by the EPA as a fingerprint of climate change. This shows that the very latest climate model simulations are, on average, warming the tropics 2 to 5 times greater than the real world as shown by the symbols. In other words, the models cannot tell us why the temperature did what it did in the past 35 years. Now, regarding the Ipcc now, please note that the Ipcc was written by Ipcc select scientists and that the document represents their opinions. Many of the conclusions are fine, but some of the key ones do not represent the views of the broader climate science community. For example, the headline statement from the summary for policymakers baffles me. It reads, "It is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century." First, the Ipcc relies on climate models to distinguish natural from human-caused climate change. However, as demonstrated in the chart, these same models fail to represent the climate of the past 35 years by a significant amount. But in its conclusion, the Ipcc now claims more confidence that the models can distinguish natural from human change in correct proportions over a period of time during which the models failed. So, if the models can't tell us what has happened, how can they tell us why it happened? It just doesn't make sense to me. I see two things here. One, we need to go back to the drawing board on climate modeling with a rigorously independent validation program or red team approach. And two, the world community needs to be exposed to the real debates of climate science rather than the statements of a carefully selected few. 17 years ago, in March 1996, I testified before this committee about climate change and new data sets my colleague Roy Spencer and I pioneered. Using these data, Richard McNider, also of UA Huntsville, and I wrote a paper in Nature magazine that indicated climate model simulations were warming the planet about 4 times too fast. Now, over 17 years later, we still see the latest climate models warming the key region of the tropical atmosphere about 4 times too fast. In a paper published last week, Swanson demonstrated that these latest models are actually getting worse. It was clear at that time, and agreed to by nearly everyone, that our understanding of how the climate system works was poor, and we needed more observations to better understand natural variability. One of my concluding statements 17 years ago was, and I quote, "Without a continuing program of research that places climate variations in proper perspective and reports with improving confidence on their causes, we will be vulnerable to calls for knee-jerk remedies to combat climate change, which likely will be unproductive and economically damaging," end quote. Regulations have been put forward based upon those climate model projections. I have shown in previous testimony that these regulations will be unproductive in terms of climate effects, and I will let economists answer the question about whether the economic effects of higher energy prices will be damaging, especially for the poorest among us. In summary, we have a lot of work to do to understand why the climate is not changing according to popular projections, projections that, unfortunately, have been used to create policy. Thank you very much.
Thank you, Dr. Christie. Dr. Titley.
Thank you, Chairman Smith and Ranking Member Bonamici, distinguished members, for the opportunity and privilege to present to you today on this very, very important topic. As mentioned, I'm Dave Titley, and I currently am a professor of practice at meteorology at the Pennsylvania State University and the founding director of the Center for Solutions to Weather and Climate Risk. I'm here in my personal capacity today, and the views that I represent are mine. In the Navy, we have, I'm just going to talk, it's much, much easier. In the Navy, we have a saying called the bottom line up front. And it's like, just tell me what I really, really need to know. So here, sir, is the way that I see the salient points for today's hearing. The first is that the climate change is very real. I was very, very encouraged, sir, to hear from your opening statement, your numerous quotes from the Ipcc. The Ipcc shows that the climate is, in fact, warming. We see that in the temperature record, in both the air and the ocean. And as you, I'm sure, know, 90% of the heat is, in fact, in the ocean. It's kind of the Willie Sutton theory. Why do we study it? It's where the heat is. The ice is collapsing. We see the ecosystems moving. We see the sea level rising. If you look at any one of these individually, you can sometimes try to figure out, well, what's going on here? But when you put it all together, it gets pretty hard to come up with something other than that the climate is changing. And we know the basics. We certainly still have questions on the details, like tornadoes, like typhoons, but we kind of understand the basics. I mean, this is cutting-edge 19th century science. Fourier, Tyndall, Arnhus all figured this stuff out in the 19th century. If you take a look at Jim Hansen's model that climate model he published in Nature magazine in 1980, it showed the rise in temperature. In fact, he was too conservative. The temperature, the global temperature, has actually risen more than what Hansen projected. And some models are going to be too slow, some are going to be too aggressive. I think there's a saying called all models are wrong, but some are useful. So what can we actually tell out of these models? So, I mean, it's hopefully we're doing more than just like looking at individual models because, you know, frankly, you don't need a brain to do that. But we understand the science, we understand the physics, we understand then what the models can help us in, and we kind of look at this in a risk framework. I mean, again, we're all sort of victims of our past circumstance, and mine is national security. I spent 32 years in the Navy. So I kind of look at this as the way that we looked at security issues in the national defense realm. We did not necessarily wait for that extreme event. I mean, imagine if this was a terrorism hearing in the summer of 2000. What would we say? Well, we'd say we've had a few events, you know, some people in Africa, we had a bombing in the World Trade Center in the 90s, but we really haven't seen a big signal. Is that where we want to be on climate? Do we want to wait for that catastrophic signal to then say, oh my God, now we need to do things? So I kind of see the system blinking red here. And why do I say that? Warmer oceans, moisture atmosphere, warmer air temperatures. Does it mean that we've seen that catastrophic signal? No. But the absence of evidence is not the evidence of absence. So we don't know, and there's a big, big difference between not knowing versus saying, well, since we haven't seen anything, therefore it's not going to happen. So I kind of would look for a risk management strategy. I was very happy, sir, to hear about the Weather Forecasting Improvement Act. As you may know, the Department of Defense and Department of Navy have funded, starting with President's Budget 13, a program called Earth System Prediction Capability. It is interagency. NOAA is participating. I would strongly encourage and hope that the committee can help NOAA further participate in that, along with NASA, Department of Energy, and Department of Defense. The idea is to get better at everything from 0 hours, or today's forecast, to about 30 years, because this is where, in the real world, we make our budgets, we make our decisions. It's sort of, you know, our infrastructure decisions. If you're a city planner, if you're an emergency manager, you know, seasons, years, that's where we need to get better, that intersection of weather and climate. As Dr. Christie said, there's a lot to learn there, and I hope we can help out. Thank you very much, sir.
Thank you, Dr. Titley. Dr. Pelkey.
Chairman Smith, Ranking Member Bonamici, thank you for hearing my testimony today. I'm a professor of environmental studies at the University of Colorado. Before I jump into my substance, I do want to say I was an intern on this committee in 1991 under George Brown, and I have a lot of respect for the work of the members and the staff, and it's always great to come back. I have 3 take-home points, and then underneath that I'll have a few more specifics. Number 1, there exists exceedingly little scientific support for claims found in the media and political debate that hurricanes, tornadoes, floods, and drought have increased in frequency or intensity on climate timescales either in the United States or globally. 2, similarly, on climate timescales, it is incorrect to link the increasing cost of disasters with the emission of greenhouse gases. 3, these conclusions that I've just reported are part of a broad scientific consensus, including that recently reported by the Intergovernmental Panel on Climate Change in its 5th assessment report, as well as a special report it did last year on extreme events. So here are a few more specifics. Globally, weather-related losses measured in dollars have not increased since 1990, when the data starts being good, as a proportion of GDP. Insured catastrophe losses have not increased as a proportion of GDP since 1960. Hurricane landfalls have not increased in the United States in frequency, intensity, or normalized damage since at least 1990. The same holds true for tropical cyclones globally since at least 1970, again, when the data is good. Now, people in New York and New Jersey might not agree with this, but the United States is actually in an extended period of relatively good luck with respect to hurricane landfalls. We haven't seen a Category 3 landfall for the longest time period since 1900, at least. If rates return to the historical averages, we will see much more hurricane damage than we have in recent years. Floods have not increased in the U.S. in frequency or intensity since at least 1950. Flood losses as a percentage of U.S. GDP have actually dropped by 75% since 1940. Tornadoes in the United States have not increased in frequency, intensity, or normalized damage since 1950. And based on research that we've done, there's some evidence, in fact, that they've actually declined, the strongest tornadoes. Drought has, and I quote from a U.S. government science assessment report, for the most part become shorter, less frequent, and cover a smaller portion of the U.S. over the last century, end quote. Globally, and I quote from a paper in Nature, there's been little change in drought over the past 60 years, end quote. Now, that being the case, it is also true that the absolute cost of disasters will undoubtedly increase significantly in coming years due to greater wealth and population in locations exposed to extreme. So disasters will be an important focus of policy, irrespective of the future course of climate change. Now, to avoid any confusion, because this issue is so politicized, I thought I'd make a few further statements to put my testimony into context. Humans influence the climate system in profound ways, including through the emission of carbon dioxide via the combustion of fossil fuels. And again, I point you to the Ipcc, which has been mentioned as the authoritative basis for that statement. Researchers have detected and in some cases attributed a human influence in other measures of climate extremes beyond those that I discussed in my testimony, including surface temperatures, specifically heat waves, and some measures of precipitation extremes. The inability to detect and attribute increasing trends in the incidence of hurricanes, floods, tornadoes, and drought does not mean that human-caused climate change is not real or of concern. It does mean, however, that some activists, politicians, journalists, corporate and government agency representatives, even scientists who should know better, have made claims that are unsupportable based on evidence and research. Such claims, when they're made, could undermine the credibility of arguments for action on climate change. And to the extent that such false claims confuse those who make decisions related to extreme events, they could lead to poor decision making. A considerable body of research projects that various extremes may in fact become more frequent and or intense in the future as a direct consequence of the human emission of carbon dioxide. Our research, and that of others, suggests that even assuming that these projections are true, it will be many decades, perhaps longer, before that signal of human-caused climate change can be detected in the statistics of hurricanes. And the same holds for the other phenomena that have the same statistical properties. If you're looking for evidence of climate change, don't look at extreme events. Our decisions related to climate change will take place long before we have certainty on that topic. Thank you for the opportunity to provide this testimony, and I look forward to your questions.
Thank you, Dr. Pelkey. And let me recognize myself for questions and then the ranking member. Dr. Christie, let me address my first couple of questions to you. And the first is this, that some people, like the President and EPA Administrator Gina McCarthy, have made this assertion, quote, 97% of climate scientists think climate change is real, human activities are contributing to it, and that it presents a big threat to our planet. Is that an accurate statement?
No, not at all. That statement came from a question that was relatively benign about do humans have some effect on the climate, and it only used 77 respondents out of several thousand, so it was highly selective. And the American Meteorological Society, by the way, did do a survey of its professional members and found only 52% said that climate change of the past 50 years was due mostly to humankind. So a 52% amount is quite small, I think, in terms of confidence.
You think the 52% is much more credible than the 97%?
Oh, yes, it included over 1,000 respondents.
Okay. 52%, I don't think by anybody's definition is a consensus, by the way, so I'd say that there is not necessarily a consensus. My second question is this. Some scientists have claimed that the recent 15-year pause in global warming has been caused by the additional heat being absorbed by our oceans. Is that true?
Well, that's a speculation at this point because the data are very imprecise when you go down below 700 meters in the ocean. And so not having real good data, it's hard to make conclusions about that. However, even if it is true, what it indicates is our models cannot express accurately what is actually happening in the climate system.
Okay, thank you, Dr. Christie. And Dr. Pelkey, a couple questions for you. The first is over the last half century, and I think you testified to this as well, the scientific community has not been able to detect any increased frequency or intensity of hurricanes, tornadoes, droughts, or floods. So there's been no scientific, I think, proof that any of these types of extreme weather have increased over the last number of years. That's been confirmed by the Ipcc, which I quoted in my opening statement. That being the case, what does that say about any projections as to the future number of extreme weather events?
We did a study where we asked the question, let's look at climate model output, assume that it's true, and then look back and say, when would we have detected those changes? And we looked in the statistics of hurricanes. It's a little bit like saying you're playing blackjack with a shady dealer, and he puts an extra ace into the deck, and you say, how many hands would we have to play before we have some statistical evidence that there's a change in the composition of the deck? And the answer is that it is the better part of a century or longer before we would be able to detect the changes that are currently projected. So there's no physical basis, actually, for expecting that we would be able to detect those signals today, even assuming that those signals are there but will emerge deep into the future.
Okay. Thank you, Dr. Pelkey. One more question. Recently, there was a national TV ad run by the Natural Resources Defense Council that indicated that, quote, taking action against climate change, end quote, would, quote, reduce extreme weather events like Hurricanes Katrina, Irene, and Sandy. Is there evidence that these storms have been driven by human-caused climate change?
There's not presently that evidence, and further, there's not evidence that we have a discernible impact on the future rates or intensities of those storms. There's a lot of good policies that can be put in place to deal with the threats of extreme events, including hurricanes.
Yeah.
And there's also a lot of good reasons to discuss energy policy changes, including greenhouse gases. But modulating the future rate of extreme events is probably not high on that list.
And particularly with Hurricane Sandy, just to go back to that hurricane, there was a great deal of damage in part because it hit highly populated areas, not because the storm was severely or unusually strong, as we pointed out today. It's Hurricane Sandy that has been embraced by a lot of people as an indication of climate change causing extreme weather like that hurricane, but you don't think there's any truth to that?
Well, actually, Hurricane Sandy was not even a hurricane-strength storm. It was incredibly intense, had massive damage, but the main reason it had massive damage was because it hit one of the most populated, wealthy parts of our coastline. Had it actually taken that left turn in Nova Scotia, it would have had much less impacts and been much less...
but again, no correlation between weather change and Hurricane Sandy as such.
Right.
Okay. Thank you, Dr. Pelkey. That concludes my questions. I'll recognize the gentlewoman from Oregon, Ms. Bonamici, for hers.
Thank you very much, Mr. Chairman, and thank you to all the witnesses. Dr. Titley, some people assert, and I've heard this, that there's been no warming in the global climate temperature since 1998. Did global warming end in 1998?
If only. That would have made everything so much easier. As we've already heard there, the temperatures have not stopped warming since 1998. And in fact, NOAA's data show that for the United States, 2012, not 1998, was the warmest year for the continental United States. As has already been mentioned, the oceans continue to warm. And while we would always want better data, and I think I agree with Dr. Christie, it's something we do agree on, that a monitoring system is in all of our interest. Having said that, the Argo floats and the altimetry data for the ocean unequivocally show that this is where the heat is going. Now, why is it going there is an open question, but it is going there, and 90% of the heat is in the ocean system. So the Earth continues to warm, and there's some very recent research that shows it might be warming even faster now. So, yes, ma'am, it is warming.
Thank you. And I have a couple more questions. Dr. Titley, you've used the term all systems are flashing or blinking red in the climate. And could you expand on that? What do you mean by that in terms of weather? What could we anticipate in the coming decades as a result of climate change?
Yeah. With respect to whether we can tell this to let's say, a 95% confidence level, a normal statistical way, Dr. Pelkey is right that it's going to take a long time. However, do we wait for like hundreds of terrorist attacks to say, there's a statistical change that something may be going on here? So for the system to be blinking red, simply looking at the amount of additional moisture and amount of additional heat in the ocean and the atmosphere, we know hurricanes are basically heat engines. One of their main factors is how warm and how much heat do you have in the upper ocean. We know that's increasing. So it's a little bit like playing with a loaded gun here. Now, is it going to go off? Well, maybe yes, maybe no. But you look at the typhoon that went into the Philippines, strongest winds ever recorded on landfalling. Is that climate change? I don't know. But the atmosphere lined up with the ocean to create one of the most strongest storms we've ever seen.
Thank you. And Dr. Titley, you, as established, previously served in the Navy as a Rear Admiral, and you manage both weather and climate programs. So people sometimes have a hard time seeing how changes in climate change and changes in weather, how that matters in their lives. So can you talk a little bit about the Arctic? Because I think that's a place where you can really illustrate how these changes have real-world consequences for the United States. And I know there's something about that in your written testimony, but could you expand on that briefly, please?
Yes, ma'am. I sometimes tell people that we plan for climate, but we live in weather. And that's really what it is. It's, what climate is the card deck from which the weather hands are being dealt. So we see that card deck changing faster in the Arctic than in any other place. So for the Navy, we see the climate is changing. So from a security perspective, the Navy needs to be ready, one of Chief of Naval Operations' 3 tenets, be ready for a changing environment. And it's really not a political issue because we would make sure we have plans for changes in economics, demographics, political situations. So why wouldn't we plan for changes in the physical situations? So one of the things we need is better weather forecast if we're going to work up there, and that's what the Earth System Prediction capability is to help us with, ma'am.
Right. Well, thank you. And I have a follow-up on that. And I, again, want to thank the members of the subcommittee for working on the weather forecasting bill with all of us. Dr. Titley, from an economic perspective, and you touched on this briefly when you talked about, the analogy to security. From an economic perspective, isn't it wise to prepare for severe weather events and save property and perhaps lives rather than simply responding to them after they happen? I want to note that the Reinsurance Association of America has begun to adjust its business model to reflect a rising number of catastrophic events. They recently sent a letter with recommendations for policymakers along those same lines. I would like to include that for the record, and we will submit a copy with.
Okay, without objection, that will be made a part of the record.
Thank you. So from an economic perspective, isn't it wise to prepare for these events rather than just respond?
Yes, ma'am, very briefly. As you mentioned, the insurance industry, the reinsurance industry, sees a number of weather catastrophes, by their definition, significantly increasing. The part I find interesting is they also look at geophysical, like earthquakes, tsunami. Those aren't going up. So you can't just say, well, there's more people, more wealth living by the ocean. The weather part is going up, and of course, preparation is always better than reaction.
Thank you very much. My time has expired. I yield back.
Thank you, Ms. Bonamici. The gentleman from Texas, Mr. Nalgabar, is recognized.
Thank you, Mr. Chairman, and thank you for calling this important hearing. Dr. Pelkey, when we talk about a lot of these extreme weather conditions, we tend to talk to them in the context of cost. What did this event cost? What did that event cost? And so some have even suggested that when you start to talk about climate trends, that you somehow associate the cost of these disasters with the cost of these climate changes, climate trends. Is there a relationship between these financial damages and extreme weather events and long-term climate trends?
Yeah, a lot of care has to be taken in looking at cost damage because, like anything else in the economy, it changes quickly over time. We have more wealth, which is a good thing generally, but that means more property, more exposure to losses. And so it is, you're setting yourself for errors by taking, say, the raw Munich reinsurance data and coming to some conclusions about the climate system. There has been a number of studies that have tried to normalize those economic records to try to say something about the climate data. And there's several dozen of them now, and they come to a remarkable consensus that there is, in fact, no signal of human-caused climate change in the economic loss record, really globally, but also in individual locations around the world.
Dr. Titley showed a figure in his testimony that displayed the number of natural catastrophes worldwide by, I believe, Munich reinsurance. Is there any basis for claiming that any part of the increases in disaster losses can be attributed to human-caused change?
Yeah, Munich Reinsurance, which is one of the world's largest reinsurance companies, had that exact same question several years ago. So they funded a big study at the London School of Economics to actually go into their data and look at that. And you'll see that's cited in my testimony. They found that no part of that increase in global disaster losses could be attributed to human-caused climate change. So that was their own research submitted to peer-reviewed outlets, which I think is pretty consistent with what the rest of the research community has concluded. So I think there's a pretty strong answer to that question.
The warning coordination meteorologist at NOAA Storm Prediction Center in Norman, Oklahoma, Greg Carbon, I believe, stated that there really is no scientific consensus on connection between global warming and tornadic activity. Jumping from large-scale event like global warming to relatively small-scale events like tornadoes is a huge leap across the varieties of scales, end quote. Dr. Christie, Dr. Pelkey, do you agree with that statement?
Yes, that sounds reasonable.
I'll say that, yes, that statement sounds reasonable, and we've actually looked at the tornado record, which is complicated by the fact that there were different ways to measure tornadoes that the Weather Service has used over time. And one of the most interesting features of the tornado record is that if you look at the damage that's been caused, which is an independent record from the tornadoes themselves, there's actually been a decline over many decades. So that gives us some reason to think that the evidence that you see, there's certainly no evidence of an increase in tornadic activity, especially the most damaging ones. But there is a slight hint that perhaps even there may be a decrease in recent decades. I wouldn't put too much weight on that, but it's much stronger on the lack of increase side.
And the last question, what is the danger that we begin to try to tie these two together in the debate and the discussion that we're having on climate change?
Yeah, I guess I would say that these are really two important issues. Climate change, the effect that we have on the planet, is an important issue. Extreme events, both nationally and internationally, as we saw in the Philippines, are also an important issue. And if we begin using extreme events as kind of a poster child for energy policy, we're doing a disservice to both debates. So I think it's important to understand what the science says. And if the science says there's no linkage, then let's not force that. Let's take these issues apart and have a reasonable policy discussion rather than a proxy debate through the science.
Dr. Christie, your reflection on that?
Dr. Roger Pelkey said it correctly that preparing for extreme events is something we should always be doing. I like the idea of the Weather Service being given extra resources to do that for forecasting, but also in preparation of our infrastructure and responses and so on. That is good no matter what the climate might do in the future.
But those who try to tie the cost of those two to kind of impute that into the cost of climate change, are they doing the debate a disservice?
Yes, and I yield to Dr. Pelkey on that. He's done quite a bit of work, and he is exactly right that that linkage needs to be broken right there.
Thank you, Mr. Chairman.
Thank you, Mr. Nagelbauer. The gentleman from California, Mr. Takano, is recognized.
Dr. Titley, I'm interested in this question about reinsurance. It's been stated here at this hearing that no costs heretofore can be demonstrated to have been attributed to climate change. But can you tell me whether you know about reinsurance models going forward, whether climate change science has affected their modeling and their understanding of risk?
Just very briefly, sir, what I can tell you is the reinsurance industry is intensely interested in how the climate is changing because it's a business issue for them. So it's not a politics issue, it's business. And when they see the number of weather catastrophes increasing and increasing significantly, they've got to wonder how is that impacting their business. They may or may not be statistically related to climate, but I'll tell you, I lived on the Gulf Coast, and when I watched my hurricane premiums go from about $600 a year to $6,000 a year, there's real impact. And they're not coming back down, and we don't see them coming back down. So I think there's a real impact in both the insurance and reinsurance industry as we price the risk of extreme weather.
Do you agree with some of the claims made that there is no association between climate change or tornadic activity?
Well, thank you certainly for that question. Words matter. And, I was almost going to start nodding my head up and down with the other witnesses until I heard that there was no linkage. There is a tremendous difference between no linkage and a linkage that is not known. It's only a subtle word change, but there is a really big difference. I think the scientific consensus is not that there's no linkage. The scientific consensus is we don't know. And that is a very, very important definition, sir. But we do know we have a warmer and more moister world, and that means that we need to really be careful because we know both with severe weather, with big thunderstorms, and with hurricanes, those are one of, not the only, but those are primary important ingredients to creating big storms.
Also, could you comment on the claim that that there have been no increase in extreme weather events?
Yes, sir. I think it really matters, again, how do you define extreme weather events? I looked up the definition of extreme since I thought we were going to be talking about that today, and one of the main definitions is away from the center. Again, just take the basic data. We have had for the last 36 years, since President Ford was in office, above normal temperatures. That's away from the center, and they're getting further and further away. Now, if you take each year as kind of its own thing, imagine like flipping a coin 36 times and getting heads. I mean, if that's a fair coin, I want to go to Vegas with you, because the odds of that are about 1 in 68 billion. To put it another way, there's a 400 times chance, greater chance, that you're going to win the Powerball, which is 400 million, by the way, this week, than getting 36 coins to flip heads in a row. So I would say that is extreme. And the ice in the Arctic, that's extreme. We have seen geologic changes in less than 10 years. That's pretty extreme, sir.
Moving from the independent assessment of business people and reinsurance, you come from a military background. How has climate change science affected the hard-headed decisions about what the Navy or other armed forces are having to do to adjust? Is climate change science having an impact on those sort of decisions?
Yes, sir. It's in the the highest level strategies of the Department of Defense. It's in what the DoD calls the Quadrennial Defense Review. Climate change is talked about there. I could go through very, very quickly just about 3 places. The Arctic, it's opening up a whole new theater of operations. That's being driven by climate. Infrastructure and sea level rise. We haven't talked much about sea level rise, but it is a huge issue, probably up 2, 3, 4 feet. We were just in Norfolk. I have a graph in my testimony that shows exponentially rising hours of flooding in some Norfolk neighborhoods. The Department of Defense is worried about that. The Navy is, and people ask, why is the Navy concerned? It's like it's kind of a ship thing. We have to put our bases at sea level, so it's going to be a big deal. And then finally, how does climate change potentially exacerbate conflicts? And there's been a number of peer-reviewed studies that show both the Arab Spring and Syria probably have some climate linkages. Thanks.
Thank you. Thank you, Mr. Chairman.
Thank you, Mr. Takano. The gentleman from California, Mr. Rohrbacher, is recognized for his question.
Thank you very much, Mr. Chairman. I've been running back and forth as a hearing on Afghanistan going on, and I'm sort of involved in that issue as well. Just some of the statements that pronounce your name for me, is it Titley?
Yes, sir, Titley.
Okay. Doctor, you just, is there any time period in the last 100 years when there has been a similar de-icing in the Arctic area?
No, sir, not in the last 100 years.
So in the last 100 years, there hasn't been a thawing out?
Not to the degree that we are seeing now.
Not the degree, okay. And in the past, of course, before the 1300s, there was a much less ice up there. Is that correct?
As best the paleoclimatologists can tell, the world today is warmer than it has been probably for about the last 44,000 years, sir. I think you and I had this discussion actually at a previous hearing, I remember, and I quoted the Native Americans, the Inuit, who were riding the Coast Guard cutter Healy. Nothing in their oral history showed the kind of changes that are happening in the Arctic today.
So the Greenland wasn't green. I mean, it was always icy, and Iceland was always Iceland. And from what I had understood, that at times that there's lots of evidence to suggest that there was large communities in Greenland and Iceland that actually, because it got colder, disappeared.
Yes, sir. We may be talking past each other slightly. I'm talking about sea ice, the Arctic sea ice.
Well, I understand that the sea ice had a lot to do with the Iceland community disappearing because they lost their transportation for supplies from Europe.
Yes. When you take a look at the Arctic as a whole,
yes,
we have not seen the diminishing or the lessening of the sea ice in thousands and thousands of years. This is
Did the
unprecedented.
other two witnesses agree with that assessment?
Not at all. I think he might have misspoke on the 44,000 number, but the globe, especially the Arctic, has been much warmer in the past than it is today, and there's plenty of evidence to support that. As well as the sea ice, that's a bit more murky on how much sea ice was there at any particular year, but it does look like it had receded much further, especially in the mid-Holocene period, 5,000, 6,000, 7,000 years ago, when Greenland was much warmer than it is today.
Okay.
The globe, sir, has been warmer in the past. It's warmed and it's cooled. Climate has changed for millions of years. It will change for millions of more. The difference is in about the last 8,000 to 12,000 years, we've had very stable climate relative to what climate normally is. And that's when we've built human civilization. It's why we put our cities where we did. It's where the agriculture is where it is. So if we start changing that for whatever reason, that becomes a huge issue that humanity as a whole will have to deal with. So, yes, the climate does change. That's not the issue.
Just in terms of we talked about the Arctic, do you agree with that? It's never been warmer in the Arctic?
Overall, it has not been warmer for thousands of years in the Arctic.
We have one disagreement with Dr. Pelkey.
It's not my expertise, so I'm happy to let those guys
Thank
fight
you
it
very
out.
much. Let me just ask, so, I sat through Hurricane Hazel back, I lived in North Carolina at the time, remember the trees, and it was, that was a pretty strong hurricane back in the 50s. Was that stronger than Sandy or weaker than Sandy?
It depends how you measure the strength. If you measure by the winds, and I think it's already being brought up that two of our most destructive hurricanes have actually been really pretty, by the Saffir-Simpson scale, pretty weak storms. Katrina, not many people realize this, was actually a Category 2 when it made landfall. Yeah. Sandy was not even technically
now, a lot of the damage that we're talking about is not based on the climate or the strength of the wind, but instead where the people have built and what kind of houses.
And it is built. Storm surge, sir. And it's a storm surge with a rising
and
overall.
Do we have, you mentioned that the sea rates have gone up, the ocean levels 4 or 5 feet. Do our other witnesses agree with that?
I don't think you mentioned
what I said.
that high. It was someone's projection, I think.
Yeah,
what you were talking about. It has not, and it has not accelerated either. Either the sea level has not been accelerating in terms of its rise and level.
So over the centuries, you're suggesting sea levels are rising, and you're suggesting that they're not. Is that correct?
Well, the data do show the
sea level is rising. It's just at a rate that is not accelerating.
I see.
Well, it is accelerating. It's right now 3.2 millimeters per year, and it is accelerating. And we're going to deal with 2 to 3 feet by the end of this century, at least.
And we're accelerating from what time period? Was it accelerating? We see these pictures of the continents and everything changing. If the continents can change and the sea level rises and changes then before mankind is ever around, you see, most every time when you're suggesting that this is due to climate change, we're not really talking about climate change. We're talking about man-made climate change, because what you're saying is then being used as an excuse to control the activities of mankind. Correct?
Okay, Congressman, I don't get into the politics. When I did this in the Navy, the reason we looked at this is because the battle space was changing. Now, why the battle space is changing was not our core interest, but we saw the battle space was changing. But when you then walk back to physics, if you put in greenhouse gases, it's changing it. So from a policy perspective, how do we deal with the greenhouse gases? You can regulate it, you can use market forces, you can do a number of different things. But, this is cutting-edge 19th century science, so whether we're going to deal with that or not, but that's kind of the crux of the matter. So the sea level...
You're right, it is the crux of the matter, and if we try to suggest that we know that climate is always changing, but if we are suggesting that the greenhouse gases that mankind puts into the air, of course 90% of the greenhouse gases come from natural sources, but if we are suggesting then we have an excuse to control human activity. And quite frankly, controlling human activity is not necessarily consistent with the founders of this country who believed that human beings have rights to control their own actions. Thank you very much, Mr. Chairman.
Thank you, Mr. Rohrabacher. I'd like to follow up on a subject that Mr. Rohrabacher brought up and asked Dr. Titley and Dr. Christie this question. As I understand it, some people point to the decrease in Arctic sea ice as an indication of a calamity or a red flag. Arctic sea ice went down for a number of years, actually went up last year. The Antarctic sea ice has gone up, increased for the last 30 years. And when you combine the two, the amount of sea ice, Antarctic and Arctic, is actually above the average over the last number of years. So why should we be concerned about some diminution of Arctic sea ice when the total sea ice is above average and when Antarctica has been going up? Dr. Titley and then Dr. Christie.
Thanks, sir. Just very briefly, when the Arctic sea ice goes down, it goes down in the summer. That allows a lot more heat to get into the atmosphere because it's summertime. The winter ice in the Antarctic is increasing. There's already no sun down there, so it doesn't matter. I tell people the difference between the Arctic and the Antarctic, it's people, not penguins. So the difference in what's going on in the Arctic profoundly affects human civilization. The difference going on with the winter sea ice in the Antarctic really doesn't affect anyone. So it's a matter of changing the global balance. The Arctic is kind of the northern hemisphere's refrigerator, and we're kind of getting rid of the refrigerators.
Okay. Thank you, Dr. Titley. Dr. Christie.
Yes, the Arctic is different because it's a confined space. The Arctic ice cannot grow really much more than what it is because of the land area. And it's not correct to say that the Antarctic sea ice doesn't have an effect. In fact, because it grows outbound to lower latitudes, it actually increases the albedo of the Earth. And so it does have a profound effect, even more so than the albedo change of the Arctic ice because of the angles of solar inclination. So, the global sea ice is above average right now. And that's something, we can't predict. You can't find a single model that's able to show that result.
Okay. Thank you both for answering that follow-up question. I think we have no other individuals to ask questions, so thank you all very much for your expertise today, for the information you have provided us. We very much appreciate it, and we stand adjourned.